Hello everyone, I am Ramanjam from AML department. Today I will be explaining the QR decomposition in Python using the Gram-Schmidt process. QR decomposition is a method of making a matrix into breaking two simpler matrices. One is orthogonal matrix and the upper triangle matrix. This technique is very important in linear algebra because it is widely used in solving linear equations such as linear least square problems and eigenvalues computations. So in this presentation, I will walk through the code step by step and show how the algorithms works. Let's share my PPT. This is my PPT when I share this. Now I already explained that QR decomposition is a way of factorizing a matrix into the two simpler parts or two simpler matrices. So the orthogonal matrix Q represents the orthogonal matrices and the A represents the upper triangle matrices. So we can have A is equal to Q, or this is widely used in numerical linear algebra such as solving linear equations problems, square and problems. And the Gram-Schmidt process defined as given a set of linear independent vectors, the goal is to convert them into a orthonormal sets. So the independent vectors convert into an orthonormal sets. A1, A2, A1, AM is convert into Q1, Q2, and QM. So the steps means the in this process first the start with the first vector Q1 is equal to A1, and that are orthogonized the second vector and then orthogonized into third vector. Continues for all these columns to get the values Q and R. We can represent the QR matrices. First the code. So first we can importing the library. First step we can importing the libraries. We can import the numpy as np. And second step for the numerical operations, and we can define the function. We can define the functions QR decompositions. So n comma m is equal to a dot shapes. We can represent the we can define the functions, and n and m represents n are the rows and m are the columns. So n are rows and m are columns. And then we can initialize first, and then next step we can initializing the process q and u. So q np mt n comma n np u is equal to np n comma n. So they represents the matrix for orthogonal matrix. U represents the ortho orthogonal matrices, and Q represents the normalized orthogonal matrices. And then we can initialize the first column, and then we can initialize the Gram-Schmidt process in the loop, for loop and I loop. After that loops, we can loops to form a orthogonal vectors, and then we can print the results. So in this details, first step, I will initialize that. So importing the numpy and then define the functions. Next, I can initialize the arrays. U hold the orthogonalized vector and Q holds the orthonormal basis vector. Already told in the code explanations. And then second first column. Next step, transmitted processes. So for loop and j for I into n comma n and for j into range of n, each steps start with ui is equal to ai, subtract the process on all the previous qi. This ensures the orthogonal earliest vectors and normalize ui to get the ai ui by ui. This is all. By the end of the loop, the columns q forms the orthonormal basis. Fourth step, we can construct R is equal zeros. The R initializes the n into m zero matrices. Compute each steps Rij, Qij, that makes R upper matrices, and then print the results. So to summarize in this Python code successfully that we can perform QR decomposition using the Gram-Schmidt process. Though the A matrices, the matrix A represents the product of two matrices Q, which has orthonormal columns, and R represents which have upper matrices. The method is not only a fundamental concepts in linear algebra. It is also used in creating an linear equations, least square problems, numerical algorithms. I hope this explanation made this process clear and easy to follow. So thank you for watching.